Okay, today we're going to go ahead and talk about the last section in Chapter 5, and we'll again spend 2 days on this. So we're going to go ahead and do solving trig equations. Alright, let's just go ahead and jump right in with example 1. Use substitution to determine whether the given x value is a solution. So they're asking you, is pi over 3 a solution to this equation? So make sure you have your green sheets handy. So what you're going to do is you're going to make a substitution. You're going to take this and put it into the equation. And my question is, what is the tangent of pi over 3? And is that the same as the square root of 3? So that's the question. So you look at your little green table, and we have pi over 3, tangent is square root of 3. So yes, it matches. So yes. Okay, let's try a different one. Cosine x equals 1/2 when x is 4 pi over 3. Okay, let's go back to the, well, you can't even see what I just wrote. Let's go back to this one for just a minute before we do this one. One thing I didn't stress is, what quadrant is pi over 3 in? Pi over 3 is in quadrant 1. And in quadrant 1, tangent is positive. Alright, so you still have to keep in mind your whole idea of what quadrant you lie in. So in this one, you make your substitution for the cosine of 4 pi over 3. My question is that 1/2. Well, think about it for a minute. 4 pi over 3 is in quadrant 3. In quadrant 3, cosine is negative. And now I look at my chart. A pi over 3, cosine is 1/2. But because I'm in quadrant 3, I know I'm negative 1/2. So do the two balance? No. Alright, so hopefully that made sense. You just figure out what quadrant you're in and what the sign of your answer is, and then compare if they're the same or not. Sorry, I'm at lunch again. Alright, example 2. Find all the solutions to each equation. Before we get into this example, I want to go over a few things. Remember, the sine function has a period of 2 pi. The cosine function has a period of 2 pi. Tangent is the oddball. The tangent function has a period of pi. So I need to make sure that we remember this because it's going to affect us in this example. Alright? Now, one nice thing with these is as you're working the problem, if you get stuck, you can always come over to the side and just drop your sines and cosines and solve your equations. So for example, if this overwhelms you, then what you could do is a little sidebar. you could come over here to the other margin and put 5x equals 3x plus the square root of 3. Right? Since this is an equation, you know exactly what to do. And as you work this equation, you can come over here and mirror it. So for example, if I wanted to solve this equation, you would tell me the first thing I need to do is to get my x's on one side. So you tell me to go ahead and subtract 3x from both sides. So I subtract 3x. We'll mirror that. So over here, instead of just 3x, I've got 3 sine x. Go back over here, what would you say? Well, you'd say 5x minus 3x is 2x equals the square root of 3. Come back over here. 5 sine x minus 3 sine x is 2 sine x equals the square root of 3. Do you see again how they pattern each other? You come back over here, you say, hey, what would I do now? Oh, I divide by 2. Okay, so come over here and divide by 2. So I have the sine of x is equal to square root of 3 over 2. Now, if you were over here, you'd be done. Unfortunately, we're not. X is not by himself, so I need to get rid of the sine. So do you agree that at this point I'd really divide by the sine of x? Alright, but that looks a little bit weird. So what you're really going to do is take the inverse sine of both sides. Because if I multiply the inverse sine times the sine, I get x. Now, do you remember how to take an inverse function? Well, we go to our table here, and I'm looking for square root of 3 over 2 as sine. So square root of 3 over 2 is here, so it must be a pi over 3. Or, where else, right? That would be if I were in this quadrant. But where else could sine be a positive pi over 3? Well, if I remember, sine is positive in these two quadrants. So couldn't I also be a 2 pi over 3? So your answers are all going to have two options. And if you look back, the direction said all equations. So, what is the period of sine? 2 pi n. N just represents any number so that I could loop around 3 twirls and still be at 3 pi over 2. Okay, so when I ask for all the solutions, they're going to have that attached. For sine and cosine, tangent will just have a pi. Alright? Okay, let's try another one. Let's do 2 cosine x equals negative square root of 3. If you need to, you certainly can come over here and write down 2x equals the square root of 3. But this one's not bad, so I think I can do them without mirroring anybody. I need to get x all by himself, so the first thing I'm going to do is divide by 2. So I get the cosine of x is negative square root of 3 over 2. Now, to get rid of the cosine, I would really divide by it, but we like to just call that the inverse cosine of both sides. So I get x equals. Now, I need to figure out the inverse cosine of negative 3 halves. Okay, so square root of 3 over 2 is a pi over 6. But I'm negative. So do you agree that I'm really a pi over 6, but for cosine to be negative, I need to be in quadrant 2 or quadrant 3. So I'm either 5 pi over 6 or 7 pi over 6. So one option is 5 pi over 6, or 7 pi over 6. But I'm not done. I asked for all the solutions. So plus 2 pi n plus 2 pi n. Okay? Our next example is going to limit where you are. Solve each equation on the interval (0 to 2 pi). Okay, so couple things. First thing, you need to understand that you're really going to have two options almost right out the gate. So the first thing I want to do is I need to get x by himself. This time, though, to even get to the 2, I have to get rid of tangent. So I'm going to go ahead and take the reciprocal function of tangent. Here's where I'm going to divide it. So go to your chart. Tangent square root of 3 is pi over 3. So I could be pi over 3, or where else is tangent positive? Tangent is also positive in quadrant 3. So what's the name of a pi over 3 in quadrant 3? 4 pi over 3. Right? So let me stop, make sure you understood that. When you do your inverse tangent of the square root of 3, you know you're a pi over 3. The problem is you just don't know whether you were in quadrant 1 or whether you were in quadrant 3. So that's why I have to list both as possibilities, because what's the tangent of this function is square root of 3. What's the tangent of him? Square root of 3. What's the tangent of this one? Negative square root of 3. That's why I'm not there. Alright, now, notice I gave you an interval. So you're still going to talk about this stuff here. So I'm going to add, but this time it's tangent. Tangent is just pi n. Okay, cosine and sine are 2 pi, tangent is pi. Now let's just keep solving for x. So do you agree now I'm going to divide everybody by 2. So I get x equals, when we clean this whole critter up, I get pi over 6 plus pi over 2 times some n. N is just a number, just a constant. Or I could solve it over here by dividing everybody by 2. X is equal to 4 pi over 6 plus pi over 2n. And I'm going to clean this up to give 2 pi over 3. Alright, so now let's talk about our solutions. I'm going to start with this guy first. Pi over 6. Grab your calculators. Now, I'm going to add pi over 2 to that. So again, if we want to use our little calculators, we're just going to ignore the pi's. So 1/6 plus 1/2, is that under 2 pi? Yeah, 2/3 is less than 2, so 2 pi over 3. Okay? Add a half again. So 7 pi over 6. Add a half again, because I'm not to 2 yet. 7/6 is still less than 2. Oops. Okay, 5 pi over 3. 5/3 is still less than 2. Add a half. Do you see now I'm above 2? Right? I'm at 2.166, so this number doesn't count. So now I'm done with the first guy. I come over here to the second guy. So I start out with 2/3 pi. You see I've already accounted for it, so I don't need him. But I need to see maybe if I get somebody, if I do 2/3 plus a half. Maybe that'll be somebody new. He's under 2, so that's a good thing. 7 pi over 6. Oh, I have that one too, so I don't have to write him down again. All right, let me add another half. 5 pi over 3. Oh, I have him too. Sometimes you'll get duplicates, sometimes you won't. When I add a half, I'm done. Okay? Tangent is really weird. Really, we didn't have to do this for tangent, but I think it's easier if I just show you the same model for all the trig functions. What's neat is tangent, you're just going to get all your answers from him. So this guy wasn't necessary. But he would be necessary for sine and cosine, so that's why I just like to teach them all that way. Alright, let's see if we have time for one more of these. And then in class tomorrow, I have something super easy to show you. Alright, let's add the sine of x over 3 is equal to 1/2. So first thing I want to do is I want to get rid of the sine function, so I'm going to take the inverse sine. So I get x over 3 is equal to, and at this point, remember, I'm going to break. So I need to figure out what quadrants I'm in. First of all, I need to figure out what gives me 1/2. So what is the angle that's attached to the sine of a half? It's a pi over 6 angle. So if you need to, you can drop pi over 6 wherever. And he's positive. So what quadrants is sine positive in? 1 and 2. So in quadrant 1, he's truly named a pi over 6. In quadrant 2, his name is 5 pi over 6. Okay, we need to do one more thing. We need to remember that because I'm dealing with a sine function, his period is 2 pi. Now again, I'm trying to solve for x, so I'm going to multiply every term by 3. So x is equal to pi over 2 plus 6 pi n, or x equals 5 pi over 2 plus 6 pi n. Alright, so now we're ready to get started. So I start with this guy. I know pi over 2 works. So now I can do 1/2 plus 6. Do you see that right away I'm over 2? So I'm done with him. Come over here. Now, I know you want to put down 5/2, but isn't 5/2 too big? So my only solution is this guy. So sometimes you get one solution, sometimes you get multiple. Okay? Alright, so I think that's where we'll leave off tonight. We'll do a couple of easy practice problems, and then we will go ahead and touch base with this tomorrow.